our world and beyond. Space, in partnership with the European Space Agency.
Europe's newest spacecraft is readied for a crucial test off the coast of Sardinia.
It's an experimental vehicle. We are experimenting things in all kinds of ways.
It's an experiment that will test the machine to its limits.
One of the most difficult things in space business is re-entering the atmosphere.
Each step of the way, the spacecraft will be watched and analyzed.
These tests that we're going to perform in these days is very important to make sure that we have a robust design to withstand the last phases of the mission.
A mission that ends in splashdown.
And it's something that Europe has never done before, and so it is a very challenging project.
It's sunrise at this small port near a military base in Sardinia. On board are Italian soldiers and a handful of anxious space engineers. They're about to test a new spacecraft known as the IXV, or Intermediate Experimental Vehicle. Today, it will be dropped into the Mediterranean.
So we're ready to go. Weather conditions seem to be perfect today, so we are really all pushing to perform the test this morning. The plan is to go out now and free the field, so to be sure that nobody is in the test range on the seaside. So we will free the ground, and then the helicopter should go and pick up the prototype, should fly over the area, reach a certain point at 3,000 meters altitude, drop the system and perform the test. We are closing in this boat the access from the north to fishermen's and boats. So there is another boat like this which is closing the access from the south. And so the test scenario is perfectly ready to run the test in approximately half an hour.
Nearby, the IXV is readied for action. A lot of ambition is riding on this prototype as it represents a new chapter in spaceflight technology for the European Space Agency. The idea is to have an affordable small spacecraft that can enter near-Earth orbit and then land in a targeted zone on Earth. Today is just one step in development. In 2014, the IXV will be launched into space and then re-enter the atmosphere.
The Americans, the Russians, the Chinese have these capabilities, so to come back from orbit. We believe that it is very important for Europe to maintain and to develop this technology.
The IXV hasn't been designed to carry humans, but will carry valuable payloads.
One could imagine one day in which we will go to orbit, operate in orbit, even with future generation of satellites for possible refueling, for high altitude and atmospheric research, for monitoring, for disaster monitoring. So we can have several civil applications that could be beneficial for the space sector.
This is the Atlas, a powerful launch vehicle that will place the spacecraft in orbit. Flight testing began.
Getting back down to Earth from space has always been a challenge because of the speed and heat involved. In the early days, Soviet and American engineers developed capsules with a broad, almost flat underside.
However, the landing system was designed to use...
Europe tested its own version called ARD in the 1990s. The astronauts of today use the Russian Soyuz capsule.
Touchdown.
The capsule design means they create a buffer of hot air below them as they re-enter the atmosphere. It's reliable, but it's difficult to control exactly where they land.
The shape of IXV is a lifting body shape. This means that during the descent, when the vehicle interacts with the atmosphere, the shape itself is capable to create a lift. And so the vehicle itself is capable to be guided in the descent to a more specific target with respect to our capsules.
The lifting body shape has its issues, in particular heat buildup around the leading edges. NASA's shuttle used heat-resistant black tiles on the nose and underside. In 2003, those tiles were damaged by debris during the launch of the shuttle Columbia, leading it to be destroyed on re-entry into the atmosphere.
The shuttle technology is a technology from the 70s. It worked very well, no doubt about that, but definitely the IXV is embarking more performing technologies from the thermal protection point of view. The difference with respect to the shuttle is that the shuttle was made up of several tiles, while this one is made up of big, large, hot structures elements, like for example the nose cap, which has a width of almost 1 meter.
Back on the test range, the IXV is ready to go.
5, 4, 3, 2, 1.
All eyes are on the parachute system, the panels that eject mid-flight, and the balloons that should inflate on splashdown.
4 pannelli che verranno sparati.
Mark, you see the balloons?
Yeah, collapsing. Oh no, I cannot see balloons, no. Shoots right over the object.
Splashdown, and from the headland, Roberto hears that something is wrong.
What we understood from the radio, we would like to see is that once we had the splashdown, the flotation panels did not inflate, and of course we will have to investigate why this has happened.
I getti sono in dei pannelli perfetti, ma i palloni non si sono gonfiati.
Boh.
The IXV can float on its own, but there should be 4 yellow balloons around its sides to keep it steady in the water.
I could be more happy, but we take the good part of it.
Two of the balloons suddenly inflate, triggered by the divers climbing around the IXV.
Well, when you deal with experimental systems, you know that you face risks. So honestly, probably what we achieved is not so bad. I mean, let's say it's not perfect, but it's not so bad.
Half an hour later, the IXV is heading back to the military base. Both Giorgio and Roberto think the balloons didn't inflate because the setting for the sensors that detect the impact with the water was too high. So splashdown was quite simply a little too gentle.
There has been a lot of discussion around this because we need to differentiate the shock induced by the impact with the water from the shock that could be induced by wind gusts to the parachute, because they are very similar level of shocks induced. So to differentiate these levels, we had set this threshold quite high. And while my visual impression of what happened was really that the landing was very soft because the parachute is really working fine. So probably the impact loads were much lower than what we expected.
A post-test review confirmed the splashdown was indeed softer than predicted.
We demonstrated what we wanted to demonstrate. So free fall condition initially, you see the parachute compartment where we had the extraction of the parachute system. The slings of the parachute that are covered by thermal protection system to sustain the heat of the re-entry. We wanted to test how this thing was going to be broken. And you see here the flotation devices that are activated right after the splashdown itself. Now, if there's something we'll have to fix coming out from the post-review board, etc., we will implement in the flight hardware.
On the negative side, there is the fact that we didn't inflate the balloons, but on the positive side, there is that our space segment is more robust. And also, this is the objective of the test, to push the limits, to understand what we are doing with our current design.
Today's test is just one chapter in the story of the IXV. Next year, it'll make a full return journey from space. And the engineers will be ready.
Più vicino al pallone.
Adesso, boom, boom. Grazie.